Hello everyone, welcome to Savi Tutorials. I am Amulya HG, Assistant Professor, Department of Electrical and Electronics Engineering, Savidya Institute of Technology. In today's laboratory, that is relay and high voltage, we are conducting one experiment, that is spark over characteristics of air insulation subjected to high voltage AC. So in the previous experiment, we have conducted an experiment on the liquid dielectrics. So this is the experiment on gaseous dielectric by giving high voltage AC supply. Dielectric is an insulating material or a very poor conductor of electric current. So when this dielectric is placed in an electric field, there is no current flows through it. So we have a different type of dielectric materials are there, solid, liquid and gaseous. So this experiment is based on gaseous dielectric materials. That means the dielectric material in the gaseous state. So we have a different examples are there for the gaseous dielectrics. It may be SF6, nitrogen, carbon dioxide, or the surrounding atmospheric air also we can consider. So for this experiment, we are considering the atmospheric air or the surrounding air as a dielectric medium. The purpose of conducting this experiment is in order to check the dielectric strength of a given material and also check its thermal stability. So how we have to choose the dielectric material means it should be non-inflammable, it should be of low cost, it should be non-toxic and it should need to have good dielectric strength. Dielectric strength is nothing but it is an electrical strength of an insulating material. So whenever you apply the voltage, the media, it should not convert it into a conductor. It should act as an insulator only. So that is the main important property of a dielectric material. So coming to the aim of the experiment, so here we are determining the breakdown strength of a given air by subjecting the high voltage AC. So we are giving a AC supply for the given circuit. Then we are checking how much is the breakdown voltage of the dielectric material. So now observe this. This is the circuit diagram for the given experiment. So from the input is AC supply, that is a single phase 230 voltage that will be given into the circuit. So before the supply goes into the actual connection, the supply will be going to the fuse for safety for the device and also for the operator. Next we have a door open switch is there. So this has been experiment is placed in a closed room. There is one sensor is provided. If the door is not closed properly, the supply it won't be going into the circuit. So that is why we have provided a door open switch. Then we have a tripping switch also is there, only for the protection to the circuit. So this 230 voltage, it has been fed into the step up transformer. Here the 230 voltage is stepped up into 50 kilovolt because we are giving a high voltage AC supply. Then we have a voltmeter is there for the measurement of voltage and also the measurement of the breakdown voltage in the circuit. So now we'll see the actual conduction of the experiment and also its experimental setup. The apparatus required for this experiment is the breakdown testing set. So this is the breakdown testing set. So this is the control panel what you are seeing here, and inside that we have the experimental setup is there that I'll show you. This is the control panel. Next we have a door switch here. If the door is not closed properly, then the supply it won't be going to the connections. So after that we have a step up transformer. This is, so here the 230 voltage is stepped up into 50 kilovolt. So this 50 kilovolt, once it is stepped up here, that will be going into the breakdown circuit connection. So here we are receiving the AC supply. So this is the terminal for AC supply, and here we have a rectifier is there. This is for conduction of converting high voltage DC. So this is the same experimental setup for the conduction of high voltage AC and DC breakdown strength of a air. So this is the terminal for AC connection. Similarly, this is the terminal for DC connection. So using this rectifier, the AC is converted into DC. So this is received here, and this is a switching terminal for switching to AC and switching to DC circuit. So here this whole arrangement we call it as the vertical arrangement of the sphere gap. So we can prefer any type of arrangement. It may be the vertical or the horizontal. So for the vertical arrangement we are using two metallic spheres. So this is a copper sphere. So it is provided with a proper spacing. So the distance between these two gap distance we can control, or we can increase or decrease with the help of the control panel. And this is called as a water resistor for limiting the maximum current once the breakdown is occurred. So this is the terminal for connecting to the water resistor. So through this it has been given the supply from the high voltage AC or DC. So this is the terminal, as I told you, switching terminal for giving connection to AC and DC. So through this terminal the supply is going into the water resistor. Through that the supply is coming to the two metallic sphere. So for measuring the distance, either you can note down from the control panel or you can note down here itself the gap distance between the two metallic sphere. And here you can observe the one more arrangement, that is called as horizontal arrangement. So this is the horizontal arrangement of the sphere gap. So here we can use a different type of electrodes. Here we have used a flat plate type of electrodes. Either we can prefer the projected type or the cone shape of electrode also, or the tube type of electrode also. So different type of electrodes also we can prefer. So this is in the removable form. So we can remove this and we can insert the electrode whichever we want. Since both the electrodes are of same type, so the electric field created here is uniformitous. So for arranging the gap distance between these two electrodes, here manually we have to rotate this knob for setting up or increasing or decreasing of the distance between the two electrodes. But for the vertical arrangement, through the control panel only we have to vary the distance. And this is the water resistor provided for the horizontal arrangement. And now you can observe here, so once the breakdown occurs between, or once the conduction takes place between the two electrodes, then that leakage current or the discharging current that will be going into the ground potential. So this is the ground connection box, what you can observe here. Through this box, once the breakdown occurs, the discharging current, it will be going into the ground potential through this, so that the entire device is protected against the breakdown. So coming to the conduction part, so this is the tabular column for the given experiment, that is breakdown strength of air for a high voltage AC. So here you have seen in the experimental setup there are two type of arrangements are there for the conduction of the experiment. One is vertical arrangement by using a sphere gap, and other one is horizontal arrangement by using a different type of electrodes, so that is a flat plate type, cone shape. So these are the different type of electrodes. Now coming to the first type of arrangement, that is vertical arrangement. So for the vertical we are using a sphere gap. So for the first case I am going to adjust the sphere gap distance between the two electrode as 10 millimeter. So now what we have to do means we need to set this 10 millimeter by using the control panel. Then we have to take up the readings, the mean of that value that will be noted down in the average spark over voltage measurement. So this is the control panel. Through this only we have to operate the vertical arrangement of the sphere gap. So this is the mains. We need to switch on MCB. Before switching on, we need to make sure that the voltage should be in minimum condition. So here we are receiving the voltage from the step up transformer is 50 kilovolt to up to 70 kilovolt. So up to that we can vary the voltage here. Keeping this in a minimum condition, then we have to press the HT button on. So when does this HT button on? This light will blink means only when the door is completely closed. As you have seen in the circuit diagram, from the circuit diagram we are receiving the supply through the door switch. If the door switch is not closed properly, then the supply, it won't be going into the spear gap arrangement. And before switching on the HT button, since we are doing a high voltage AC experiment, so this is the switching knob for keeping in a AC as well as for keeping in a DC. So we are doing the AC, so this knob should be in a AC mode. Then for increasing the spear gap distance, we have to use this knob. So if you continuously push this button on the decreasing side, then the distance between the two gap will be reduced. Similarly, if you keep this in an increasing side, then the distance between the two gap will be decreases. So here the gap distance should be set for the first case is 10 millimeter. So now we'll decrease the distance between the two gap. Later we'll check the distance. So for distance as 10 millimeter. Now the distance has adjusted to 10 millimeter. Now press the HT button on. So since the door is closed, so the HT button, this light is blinking. That indicates the supply is continuously given. So now using this variac, we can increase the voltage. Once the breakdown strength of the surrounding gaseous media is reduces, means then there will be conduction takes place. That means the two electrodes are conducted through the ionization by collision process. So as I am increasing the voltage here, actually you can see a spark between the two metallic sphere. I am increasing the voltage. Yeah. So you have heard the sound of the occurrence of the breakdown. So due to that, the trip button is indicating the breakdown has occurred. So for the previous case, the breakdown has occurred for a voltage of 15 kilovolt. So that we have to note down in the tabular column. So this is for the first case. So before proceeding for the second reading, we need to reduce the voltage into a minimum value. Then we have to press the HT button on. So now in the same way we can go for the second reading also by increasing the voltage. At certain point of time, the surrounding media as an insulator is converted into conductor due to ionization by collision. So due to that, we can see occurrence of breakdown between the two metallic sphere. So I am increasing the voltage now. You can observe there will be a spark occurs between the two metallic sphere. So the breakdown voltage even for the second case also, it is 18 kilovolt. By repeating the same for the third case, the breakdown has occurred for a voltage of 18 kilovolt. So that we can write the average spark over voltage for a distance of a 10 millimeter is 18 kilovolt. So similarly, we have to do this in the same vertical arrangement only. The spear gap distance, now I am going to adjust it for 15 millimeter. So the procedure will be same. We need to adjust the distance to 15 millimeter. Then we have to increase the voltage and note down the breakdown voltage at which the breakdown has occurred. Repeating the same procedure even for a 15 millimeter also, we are getting a breakdown voltage for a 3 reading as 26 kilovolt. So the average spark over voltage for 15 millimeter now is 26 kilovolt. So this is the tabular column for vertical arrangement. So now we are going for the horizontal arrangement, that is rod gap method. So as I already told you, in the horizontal arrangement we can use the different shape of electrodes, cone shape, flat plate also. So in this experiment we are using flat plate type of electrodes. And the gap distance we need to adjust it to 10 millimeter. So I told you for the horizontal arrangement manually in the experimental setup only we have to adjust the distance as 10 millimeter. So now you can observe the horizontal arrangement where the supply from the HVAC is connected to the water resistor and that is going into the horizontal arrangement, that is the flat metal plate. Now by using the control panel, I need to increase the voltage and at certain point of time there will be a breakdown occurs between the two electrodes. So now I'll press the HV button. Voltage is increasing now. So the breakdown has occurred between the two metallic sphere for a voltage of 20 kilovolt. So that we have to note down in the tabular column. So for the 10 millimeter we have taken 3 readings. So breakdown has occurred for a 20 kilovolt, so that we can write the average spark core voltage is 20 kilovolt for a distance of 10 millimeter. So same way we can increase the distance to 15 millimeter, 20 millimeter also, and the same way we can note down the average spark core voltage of the given rod gap method. Thank you.